Okay, let's see if we can do it quickly here. Medium today, find all possible stable binary arrays, part 1. You're given 3 positive integers, 0, 1, and limit. 0 is the name of the variable. Okay. A binary array, AR, is called stable if the number of occurrences of 0 in the array exactly equals the 0 variable, the number of occurrences of 1 exactly equals the 1 variable, and each subarray of array is a size greater than limit. Each subarray of size greater than limit must contain both 0 and 1. Return the total number of stable binary subarrays modulo 10 to the 9th plus 7. Okay, so find all possible stable subarray binary. So 0 is 1, 1 is 1, limit is 2. So the size must be greater than or equal to limit. Size greater than limit must contain both 0 and 1. Each subarray. I really don't understand this. Okay. The two possible stable binary arrays are 1, 0, and 0, 1. As both arrays have a single 0 and a single 1, and no subarray has a length greater than 2. Subarray of size array with a size grid must contain a 0 and 1. Please give me a harder example. So 3 zeros, 3 ones, limit 2. The possible subarrays, all possible stable binary arrays, limit 2. So I think limit refers to like the highest streak of zeros or ones, which means to say that if you have something that is the limit plus 1 length, it has to have both a 0 and 1. So yeah, I see. Limit. So here, note, limit is the longest streak of 0 or 1 within the array. So that limit plus 1 will must include both the zeros and ones, or both 0 and a 1. Include at least 1, 0, and 1. So if you have 2, I see, if you have at most 2 zeros and 2 ones connected, how many ways can you form? So this thing, so the sum of the two numbers is going to be the sum of the two numbers is the length. The sum of the number of zeros and ones. Interesting. Okay. How to compose this? Oh. Maybe dynamic programming, to be honest. And programming would be kind of n-dimensional. In this case, it'd be 200 by, or maybe 400 by 200 by 200. Something like that. Looks like that's maybe a little too big, 16 million. Yeah, maybe that's too big. 16 million. For every index. Wonder if I can leverage like the symmetry here. Maybe it's symmetric if it's like 3 versus 3, but maybe not symmetric if it's like 1 versus 2. 3 zeros. Okay, so let's go ahead and just maybe do the second example. So 0, there's one of them. There's 2 ones. So if I were to say if I were to go to each index and have a remaining count for the number of zeros and the number of ones. I guess it doesn't. I guess I can maybe just treat ones or I treat zeros or ones as a blank kind of and just consider not where I'm putting the ones. Say if I consider the zeros as blanks, I'm just considering where I put 2 ones within the length of the string, where the length is 0 plus 1. So it's basically here if I consider 3 length or 3 spots and one, there's going to be a blank, and I need to put 2 ones, and there can't be more than one blank. Well, obviously this has to be, one has to be there and there. So 0 equals 3, 1 equals 3, limit is 2. So the sum of that is going to be 6. So if I have 6 and I'm putting 3 ones somewhere within that. Three ones. It's kind of similar to like some sort of combinatorics thing, 6 choose 3. But it's definitely not that simple. And I don't think I've ever seen it be something where you use combinatorics for something where the placement has some sort of spacing. Yeah. So this ended up being 14, huh? 14. One here, then Put a 1 there. Number ways. The number of ways to put a 1 here and then the 1 here. Put a 1 here, that doesn't work, right? Because I'm left with 3's blanks and the limit's 2. Well, it doesn't work here because the limit's 2 already, so I can't. So then this has to be a blank. Oh yeah, this could be very big. Oh. Right. What the heck? What the heck? Find all possible stable. Part 1, okay. I guess part 2 might be a higher constraint. So it's probably just the same problem. Just need more up. I guess here, maybe something like n cubed could work to solve it. Where to put the ones? Where to put the ones? The number of ways you put the 1 in the first spot. The number of ways you put the 1 . Where does 6 choose 3? I'm guessing it's 30, right? No, 20. 20. And then of those 20, there's going to be 6 where they of those 20, there's 6 where there's some sort of streak of 3. Interesting. Interesting. So, can I count the number of ways that you find a streak of 3 ones? So 111, blank, blank, blank. So there's 4 ways you put a streak of 3. You choose 3. So what am I missing actually? There's only 4 ways instead of 6 ways. 6 you choose 3 is, yeah, of the 6 spots, choose 3 from where the ones are. There's 20 arrangements or combinations there. And 14 of those are ones where you don't have a streak of 3. Okay, I see. So there's 4 ways of doing it with a streak of 3 ones, and then There's another 4 ways of doing it with the streak of 3 zeros and place the ones, but there's an overlap. This is actually, there's an overlap of 2, 1, 2 where it's 3 zeros and 3 ones. Huh. This was was 3. So you could have a streak of 3. In that case, it's just all 20, right? 20 possible ways. I wonder if it makes sense to actually try to do that. Try to find the count of the number of ways to make it not possible. Subtract it from the overall n choose k. Where k is either the number of zeros or ones minus the number of ways that you can form it with streaks. Let's do something where it's, let's say, 3 zeros, 4 ones, and 2. Alright, let's go ahead and consider so baseline here. It's going to be 7 choose 3. Mental math says there should be 35. 5. Of those 35, how many ways are there to form with a streak of 3? Streak of 3. Zeros or 3 ones in a row. Hmm. 7 blanks. And we're picking 4 of them. But there has to be a streak of 3. Overlaps kill this. Overlaps kill it. Root 3. I go through every index. I go through every index. Maybe this is dynamic programming. So for dynamic programming, considering each index is the state. Each index is a state. Is that right? Each index state have include index and the number of the count of ones maybe, and maybe the current streak of zeros and streak of ones currently. Yeah, so streak maybe. And then for every state transitions to another state. So in this case, it's gonna be like 400 by 200 by, or maybe 200 by 200 by 200. And that's 400 by 200, 200. Since this can be at least, or at most 400 index. So it'd be the 16 million or whatever that I calculated before. Guess 16 million is not that bad. So it's 4 megabytes, no, 61 megabytes at most. For each index, for each count of the number of ones up to now, for each streak count. I mean, I think it would work. It's probably going to be very slow. So programming would be something like 0, times the limit plus 1. And that would be first part. Everything in range, the number ones plus 1. Everything, and that's everything in range of n plus 1, something like that. Making sure I've made this three-dimensional dynamic program matrix correct. Unmatched parenthesis, unmatched bracket. Oh yeah. Okay, I think this is correct. So it's going to be 3 rows, where each row has 2 elements, each element being a three sized array. Okay, so the outermost dimension of this dynamic program matrix is going to be the index within the overall binary array. Second dimension is the number of ones used, and third dimension is the current streak of zeros or ones. I wonder if that needs to be limit times 2. Because I need to differentiate between the current streak of zeros or the versus the current streak of ones. Can't just use it by itself. Current streak of zeros could go, so if it's 2, then it could be at 0, could be at 0, maybe that should be limit times 2, because it could be a streak of up to 2 on the ones or 2 on the zeros. Streak of 2 ones, streak of 2 zeros. Actually, that'd be limit times 2 plus 1. Okay. I'll make negatives be like the streak of zeros and positives be the streak of ones. Okay, so something like for every index in range, I guess this should be n. Zero goes to 1. N minus 1 goes to n. Yeah. So for every spot in my array, and then for every for every count of the number of ones. I think maybe this is, I initialize it better. TP index 0 and the number of ones and current streak is 0. Yeah, so there's one way. So there's one way to have the starting condition where I'm at index 0. On index 0, I have still the full 3 ones to be used. And I haven't, my current streak is 0. So for every used 1 in range, I guess it'd be 1 to 1, 1 to 1 plus 1. Maybe it should still be 0 to 1 plus 0 all the way to the number of ones plus 1. And then for everything in range, limit plus 1. I guess there should be limit, no, this should be in range limit times 2 plus 1. Actually, I think maybe I should use negative of limit to limit plus 1. Because negative limit is referring to a streak of zeros. Yeah. Okay. If the number of ways to get to the state equals 0, then skip it. Okay. And then to the transition to other states. So let's say I'm going to use another 1. So let's say if use 1 is still greater than 1, is greater than 0. Actually, I guess this would be unused ones. Increment the number of ones used, or I can decrement it. Maybe I should increment it. If used 1 is less than 1, so I've used zeros, ones, and I can use up to 3. Then, and also the streak is less than limit. Right? So it can't be at the maximum streak. Okay. Try to put a following one. So dp index plus 1, use 1 is going to be plus 1. And the streak should be what? The streak should be 1. It should be the streak should be equal to the minimum. If the streak is negative, it should become 1. If the streak is positive, it should become streak plus 1. So streak should equal 1 if streak is less than 1. Else it should become streak plus 1. So this should increase by the current value number of ways. Ways it's going to be dp index used 1 streak. dp plus equals ways. Okay. Try to put a following 0. So if yes, if the streak is spelling 0 would mean that the streak goes to more negative. If the streak minus 1 not equal to the negative limit, then the streak is going to equal -1 if the streak is currently positive. Guess this is fine. Currently positive, else streak decreases by 1. dp index plus 1, the use doesn't change because it's not going to use up another 1. Right? Either going to put a following 1 or following 0. Guess this should always be equal to mod. plus this equals ways. Maybe I could just do mod here. So if I haven't used up all 3 ones, then I should be able to do it. Should be able to do that. And then the answer is just the last bit. So answer equals 0 for every used has to be equal to number of ones. So for every shriek in range, actually, I think maybe I can just add up everything in the last column and last kind of column of the dynamic programming matrix. So answer equals the sum of dp at the last. That's kind of scary. Okay, let's do another test case. Okay, say 20 zeros, 31's limit is, let's say 17. Oh yeah, I need to do more mod. Hopefully that's the fix. Kind of close, huh? Okay, let's try to find a simpler version that I can diagnose. Say 1, 5, 2. No, it's too easy, huh? That's really close. The number of ways to get here is 0, skip. If the number of used ones is less than the limit of the number, less than the total number of ones, and the streak is not capped, then move to the next date from here, where the streak is incremented to be 1 more, or just to be 1. And then otherwise try putting 0, which should always be fine if the streak hasn't reached a negative limit. becomes -2, -3 becomes -4. Oh, I see. I see, I see. I'm screwing up my streaks here. I'm using both streaks. Let's say s equals 1. S equals 1 if streak is less than 0, else s equals streak plus 1. Use s here. And then s equals streak minus 1 if streak is greater than 0, else use streak minus 1. Alright, hopefully this is the error fix. I'm just not. Oh, shit. I'm using s in the wrong. Okay, come on. S. Streak is less than 0, else streak plus 1. Store into s. Streak minus 1 is negative limit. Then s equals -1 if streak is greater than 0, else s is equal to streak minus 1. How did that make it worse? What? Try to put the following 1. Try to put the following 0. Alright, the streak is 0. Every streak in range, negative limit plus 1. Actually, I think maybe it should never be actually equal to negative limit, right? No, I can. I can cap out at negative limit and then go +1, or I can cap out positive limit and go to -1. Streak of like a cap on the negative, a cap on a streak of zeros and then goes to 1. Cap on the ones and it goes to 0. Streak is less than limit. S is equal to 1. If the streak is less than 0, else the streak increments. Or else like take the value of the streak plus 1, put into dp index plus 1. I use number of ones plus 1. And then the streak is going to be 1 or streak plus 1. Streak minus 1 is not going to be limited. I think there should be a streak minus streak not equal to negative limit. Whoops. There should be streak not equal to limit. Okay. Wow, I'm surprised that my previous code worked at all. That was a pretty big bug. Looks like it's too slow. Don't think it went infinite. Yeah, it's just too slow. Yeah. Shucks cahoots. Yeah. Alright. I guess that's going to be a wrap for tonight. I'll try to think about it.